Hey guys, Mr. King here, and real excited. I got two scientists in my classroom right now, and they're from the University of Washington, and they're researchers in astrobiology. And I've got Chloe Hart, and then I got Joshua Krissansen-Tritton. Hopefully I got that right.
That's exactly right.
So I'm going to be asking them two things, and the first thing is just a brief introduction of your research. What is your research, and what are you doing? So Chloe, you can go first.
So I am what's called a geomicrobiologist. I am really interested in understanding how life changes the environment and the environment changes life. And I do this by studying really extreme microorganisms, so organisms from Yellowstone National Park or from the very bottom of the ocean near hydrothermal vents. And my main research question is understanding how much energy do these weird organisms need to grow. And then with astrobiology, if we know how much energy life needs, we can look for places elsewhere that has enough energy to support these kinds of microbes.
Okay, Josh?
All right. So I am a planetary scientist, and so I guess my research falls into two areas. The first is how do we detect life on planets around other stars, basically. And so what can we look for in the atmospheres of these planets to figure out if they have life? And so one of the things we've learned from Earth is that biology and life puts all these waste gases into the atmosphere, oxygen, methane, and these combinations of gases shouldn't coexist. Our chemistry predicts they should react or methane should go away. And so what you can look for are these odd combinations of gases that indicate that life is replenishing the atmosphere. And so a lot of my research is trying to quantify that idea and figure out metrics for disequilibrium of life. So that's one area. The other area is more Earth-focused, just trying to understand how Earth's atmosphere has changed through time, how carbon is cycled between the air and the ocean, the crust, and how that affects what exactly controls Earth's climate and what made Earth habitable throughout its history. So that's those are my areas.
And I'm going to throw a curveball here and make a third question. How does your research influence your research?
It's actually a really great question, and one that we've discussed at length kind of recently. So Josh mentioned looking for strange combinations of gases in the atmosphere, and one of the things that we have in common is understanding available free energy. So that's how I describe energy budgets. Is okay, I can put a number and say this microbe needs this many joules of energy to grow, and Josh can look at atmospheres and say, okay, there's this much available energy in the atmosphere with these lists of gases. So I don't know if there's anything else you want to add with that.
Yeah, I mean, that's true. We actually use kind of similar mathematics, it turns out, to do these things.
Same equations in our presentations.
But in much simpler terms, right? Just understanding the metabolisms of Earth life, what kind of gases that might produce relates in a very direct way to the things you might look for on other planets. Is that sort of simple connection too?
Yeah.
Okay. Yeah. And now here's the second question. Imagine that you're a 12-year-old again, and you're interested in science, maybe astrobiology. What was your path, and what would you recommend to 12-year-olds who want to get into science?
I recommend learning as much as you can, as humanly possible, about what you're passionate about. So as a kid, I loved playing in the dirt, looking at rocks. I liked playing with insects and identifying insects, and so my parents picked up on this, and they started buying me any sort of Christmas or birthday presents would all be related to science. And so I remember getting books that helped me identify plants and bugs. I got it was called a stargazer, and it helped me pick out constellations in the sky and identify planets. And so all of this helped fuel this passion, which was good for later on in life. I started out as a biology major in undergrad and discovered that I didn't really like the traditional biology field of study. And so I had a professor say, well, we can work with this biology degree and find a way to make it more exciting for you and find a better way for you to learn this. And he asked me the question, what did you enjoy doing as a kid? And so I said, well, I played in the dirt a lot. And so he told me, go take a geology class and see if that's the right science for you. And so I took a geology class and learned that I could actually combine geology and biology, combine those two passions, and that's how I ended up being a geomicrobiologist. So definitely don't be afraid to learn as much as you can now when you're young, and that'll help morph what you want to do in the future.
Yeah, I think my answer might actually be a little similar. I would say be really curious, right? Follow your curiosity. And that doesn't have to be just in the classroom. If you're interested in the subject, like learn about it, ask your teacher where you can find more information. Like I remember when I was younger, I just was really into astronomy, and so I just watched YouTube videos of people giving talks about interesting things they wanted to know about, black holes and gravity and things. So I think just following the things that you are curious in. My path, how I got to doing sort of astrobiology, I think I sort of went through the astronomy physics route. So I was lucky enough in high school to have the opportunity to go on like a 5-day astronomy camp. We all went to a university and got to meet with scientists, and that was really great for me because it made science like a tangible thing, like a job you could do. I didn't really know that there were people that did that, and so I would say if you have any kind of opportunity to go and see science be done, meet scientists, learn about what it means to do science, then definitely jump on that. And in terms of tangible things to get you to learn the things you need to learn to be a scientist, you obviously have to do math through high school and college. But I think a lot of kids have asked me this, like, do you have to be really great at math to be a scientist? And I don't think you do. Like, I was never spectacularly good at maths, but I worked at it and I figured it out. And so as long as you persist with it, you can learn enough to do the science you want to do. So, yeah, that's mine.
Awesome. I want to thank Chloe and Joshua for coming on out here and follow your interests, learn a lot, try different things, know your math, your science,
do
well in school as well.
Yeah.
Again, thank you very much for coming here.
Okay,
Thank you for having us.